Welcome back to Docs Off Topic. So today I thought I'd tackle something that I've been meaning to try my hand at for a while, and that is making a 3-jaw tailstock support. 80mm 3-jaw chuck. It is a Toolmaster, so probably not the best quality available, but it's what I could get on the quick, and considering the age of my lathe and the accuracy of everything else I do, within 50 microns is probably close enough. Now, that said, it's about to storm here, so I'm going to try and get as much done on the back plate for this as I can. And I'll talk as I can. Once it gets a bit too noisy, I will be packing it in for the day. So let's try and have some fun. What I have here is 80mm diameter 4140. It was when I cut nominally 40mm thick. It is now 37. I'm not facing off this bit because it's about to be drilled out. I'm about to cut a little bit of surface here, leaving probably about 13mm or so. Which will be, so this is going to be the chuck end, this is the tailstock end. So I'm just going to turn this down a little bit to get some slightly nicer surface to clamp to whilst I drill face off and bore out the other side. I've had to resort to coolant, and we're taking a 40 thou depth of cut, which for a very old lathe is actually pretty heavy, and I'm quite happy with that. That's 2mm off the diameter. Okay, how far are we? Oh, that insert is starting to wear out. But we are at 45.5, 45.6. We are aiming for 44 because I want to balance weight saving with strength, so I figure 4mm thick walls is probably adequate for the bearing support. Given it's an 80mm chuck and it's a 9-inch swing lathe and it's tiny, so there shouldn't be that much load on it. So let's get out of back gearing so we can take some faster cuts, get it down to probably about 44.5, and then we'll switch out to a finishing tip. That tip is worn out. Much better. Stringy chips, but better finish. Lucky I didn't end up with a bloody bird's nest. Surface finish isn't super great yet. Where are we? We're 44.85. One more and then we start doing the finishing. Right on 13. Alright, let's chamfer these, and then we're going to drill this out and bore it out to 28 millimeters, because that should leave us with 3.5 millimeters stop ring in the middle. Six and a half millimeter pilot. Got 'em? Help. I was curious, this should be 22, and it is. Now this bar is 230 millimeters long. And is designed for another job, shall we say. Oop. This might help. Once we've got that set up. And it's shop made, as you'll have seen by the time you see this video anyway. Only done at 28, so it is all steel. Okay. Right, that's all. What else? So I'm just doing a string pass for want of a better term, but I don't think it's actually cutting any. It doesn't sound like it. And then we'll see where we're at. I suspect we will be at about 27 millimeters. 27.15. Right. Damn. That is a proper boring bar. I'm really happy with that. I won't worry about the coolant for this. The hole doesn't have to be super precise. We are at 27.7. Alright, let's see, where are we at? We are aiming, because I don't have what I want is a stand for this, or a third hand. Alright, so we are at 1 inch 1.1065, which is 4.5 thousandths over. I'm happy with that. Okay, what I've set up here is a hard stop, which should be around about 15.5 millimeters from that surface. It should give me a little bit to just face off the bottom of that groove, or that recess that I'm going to machine, to allow the bearing to seat fully flush. Ultimately, I'll be going down 16 millimeters, which should give us just a hint of clearance. But I'm not taking it and putting it in back gearing, because I don't need it that slow. Oh, sneaky, sneaky, sneaky. $34.5. So that's 0.48 to go. Take 3 thou. So this is 34.82. Okay. So we're looking for, in the old numbers, 1.377. And we are 3, just a hair over, I think. I think my snap gauge has an issue. When it locks, it slips out just a hair. So we are at 1.371 according to that measurement. Three, 7, 2. So after numerous measurements, that is 9 point, so 34.98, 9698, somewhere around there. So I think that's about 1,000th worth of interference. That is good enough for that end. Just going to see if I can get an idea on the depth. So I've got a depth in there of 15.3. Now we want 16. So maybe a bit of a facing operation. Okay. Okay. Oh, that is actually our target. 15.9. All right. It's to diameter, it's to depth. I don't know if I can do anything about that chamfering or lack thereof down in there. Actually, I might be able to. Sneaky. So much bumping around. I've got the axle portion at the back and the inside of the ball running within tighter tolerances than the chuck that's going to be on there. I really hope that's adequate. I'm trying to take the bare minimum . I think I might switch out to the finishing. I kind of feel like I should have gone about this slightly differently. Like if I'd faced off, flipped it, and just had a tiny little bit that I'd done and then done the back, I think I would have better results. Alright, so 79, so we're a touch under what we wanted. That's okay. We're exactly where we wanted on thickness. So now, let's bring it down to this circle, and then once we've got 3 millimeters of that, 4 millimeters, then we will bring that to exact dimension. This could take a little while. And now I'm making sure that this is the most efficient way to do it. We should be within about 0.5 millimeter. Oh, yep, 10.03. We're going for 9.5. We've still got 5 millimeters excess here, which is good. We should be just about back down. Okay, a little more. Here I have this. Let's bring this down. Before it kills me. Okay. wants to start. Okay, there we go. Right, a hair's breadth looser than I would have really liked, but that allows us to bump it in if it's not 100% true on once it's on its axis. All right, let's set up the boring bar and do this last bearing recess. All right, once again, I've set up a rigid stop. I'm hand feeding this, so I'm not going to be mucking around with the coolant for this one, much like the other. Alright, let's drill the 3 holes for the backplate. They are on a centre of 66 millimeters. So this is an 80. D1 is the spigot on the other side that locates it. D2 is the hole centre. So it's 62. I know this is 79 millimeters, but we should verify that. $79.25 in fact. Let's find the edge. Okay. Now, I'm going to drill the through hole for the M6 a little bit larger to give a bit of clearance. I'm going to go with a 1/4 inch. However, my fear is I'm not going to be left with enough meat in the sidewall. They won't bottom out, so that's okay. I will leave them the way they are. I know my countersink is not going to reach there, so probably won't. Yeah, no. That's not going to drop that far down. So let's break this down. Absolutely spot on. I could have done it 6mm and they probably still would have had clearance. So that's where we have to wait now.